Hi, and welcome to Chapter 5, Challenge Problems. Again, these are the hardest of the hard types of problems. I'm going to be working, I think, 4 problems for you today. Okay, so let's go ahead and jump right into it. So this is our first problem. We have, suppose the demand function for good X is given by the quantity demanded of X is equal to 15 minus 0.5 px minus 0.8 py, where the quantity demanded of X, okay, is the quantity demanded of X, Px is price of good X, Py is price of good Y, which is related to good X. Using the midpoint method, if the price of good Y is 10, so there's something we need, price of good X decreases from 5 to 3. What is the price elasticity of the demand for good X? Is the demand elastic, unit elastic, or inelastic? Okay, so the first thing we want to do is to kind of separate out what's happening here. So the first thing that we have is we have the price of good Y is going to equal $10, and the price of good X, and I'm going to sub that 1, is going to be equal to $5. We have this scenario of quantity demanded of X is equal to 15 minus 0.5 p to the X minus 0.8 p to the Y. So what we want to do here is just put in the $5 for p to the X and $10 for the p to the Y, and then solve for our quantity demanded of good X. So from that, we end up with equals 15 minus 0.5 times $5 minus 0.8 times $10. Okay, and we're going to say then that equals 15 minus 2.5 minus 8. And when we do that math, we get 4.5. So the quantity demanded of X, and I'm going to make sure I put a 1 there, is 4.5. Now what we want to do is take a look at what happens. The price decreases from 5 to 3. So the price of good Y is still going to equal 10. The price of good X2 is going to equal $3. And we're going to use this same equation. I'm just going to go ahead and rewrite it over here just to make sure that we keep everything straight. X minus 0.8 py. Okay, go ahead and fill those things in then, and we get 15 minus 0.5 p to the X here is going to be $3 minus 0.8 p to the Y is still going to be 10, and we end up with 15 minus 1.5 minus 8, so the quantity of demand X2 is going to equal 5.5. Now we're going to have to use the midpoint method here, and remember the midpoint method is Q2 minus Q1 over Q1 plus Q2 divided by 2, doing that portion first, over P2 minus P1 over P1 plus P2 divided by 2, doing that first, and we're going to take the absolute value here. So the elasticity of demand using the midpoint method. So what we're going to end up then here, and our Q2 is going to be, let me change up colors just a moment here. Our Q2 is going to be here, a 5.5. Our Q1 is going to be the 4.5. So from that, what we get is 5.5 minus 4.5 over 10, half of 10 is 5, over 3 minus 5, half of 8 is 4, And so we end up with 1/5 over 2/4, or 0.2 over 0.5, which makes this 0.4. And because the elasticity is 0.4, we know that less than 1 is inelastic. So this answer to the problem is inelastic. Okay. Okay, our second problem says, suppose you manage a baseball stadium. To pay the salary for the star player, you would like to increase the total revenue from ticket sales. Should you increase or decrease the price of a ticket to increase revenue? So here, what we're going to talk about is the idea of elasticity, inelasticity, and its effect on total revenue. So you remember, hopefully, first let's take a second and look at the problem. So it's asking you about baseball stadiums. So let's think about that for a moment. Would you say that that's elastic? If the price increases, the quantity demanded increases a bunch? Or would you say it's inelastic? Meaning that as the price increases, the quantity demanded goes down just a wee little bit. Well, remember how we defined elasticity. That it's a luxury versus a necessity. People going to baseball games are going to be considering that a luxury. It's not something you have to do. It's not food and clothing. Because this is a luxury, we're going to recognize that that would be elastic. Okay? The manager wants to increase total revenue. So remember, in an elastic item, to increase our total revenue, what we're going to do is to decrease the price. The quantity demanded will increase a bunch because it is elastic. So here, what we want to do is to decrease the price of a ticket because more people will be able to afford it. We'll make it up on the quantity that increases as a result of this elastic item. So here you didn't really need to do any kind of calculations, just recognize that a baseball ticket is an elastic item. Okay, suppose the demand function for good X is given by, we've seen that equation before. Okay, using the midpoint method, if the price of good X is $10, the price of good Y increases from 8 to 10. The cross price elasticity. So we have the price of good X, similar to that first problem, and we have the price of good Y1, which is $8, and we have the price of good Y, which is $2, and I'm sorry, $10. And we want to calculate the cross price elasticity. So remember, to calculate the cross price elasticity, what we're going to have to do is to calculate both things here. I work them out ahead of time, so I don't have to. There we go. Okay, so first step we're going to do is we're going to say the quantity demanded of X is equal to 15 minus 5 price of good X minus 0.8 price of good Y. Okay, and we're going to say the price of good X is $10. The price of good Y we're going to keep at its first one, which is $8. So we have 15 minus 5 times 10. That should be 0.5, excuse me, I wrote it down wrong. 0.5 minus 0.8, and the price of Y, which is 8. From that, we get the quantity of X 1. I want to keep the ones together because I'm using P1. I'm using PY1 here at $8. So I'm going to say it's equal to 15 minus 5 minus 6.4. So the quantity demanded of good X for the first price of Y is going to equal 3.6. And I'm just going to say that was as price of Y equaled $8. Now what I want to do is to do the same method, and I want to calculate the price of good Y2. And so let me go ahead and do that. I'm going to change up colors here just so we can keep them all straight. So the quantity demanded of X is equal to 15 minus 0.5, price of good X, minus 0.8, price of good Y2. So make sure I keep my 2's there. I'm going to go ahead and put in the information that I know. So 15 minus 0.5, price of good X is 10, minus 0.8, price of good Y2 is 10. And given from that, 15 minus half of 10 is 5. 0.8 times 10 is 8. So the price, the quantity demanded of X2 is going to be 2. And that was at a price of good Y2, which is $10 given in the problem. So now, because we need cross-price elasticity, we have the price of good Y1 with the quantity demanded at 1. And we have the price of Y2 with the quantity demanded of 2. So we're going to use this information here and go ahead and put it into the cross-price formula. So the cross-price formula, if you remember, I'll start it over here, is just going to be the quantity of X2 minus the quantity of X1 over the quantity of X1 plus the quantity of X2 over 2 divided by 2. There we go. Do that portion first. We have the price of X2 minus the price of, I should say price of Y2 minus the price of Y1 over the price of Y1 plus the price of Y2 divided by 2. We're not taking the absolute value because this is elasticity across price. When we do that, we end up with 2, right? Because this is the 2 minus 3.6, 3.6 over 5.6 divided by 2, which is 2.8, over 10, price of Y2 minus price of Y1 over 18 divided by 2 is 9. And so we end up with negative 1.6 over 2.8 over 2 over 9, which equals negative 0.57 over 0.22 repeating, which ends up being negative 2.59. So the cross-price elasticity is negative. So do we know that's a substitute, complement? Is it a normal or inferior good? Here the price changed, right? And so when we look at this, the negative, so let's just stop and think here for a moment what exactly happened. So we can see that we have good X that stays constant in a price, okay? Y, however, the price increased. What happened to the quantity demanded? So the quantity demanded of X went from 3.6 to 2. So the quantity demanded for X decreased because the price of Y went increased. Put P's next to these. Quantity of X decreased. So we can see that these two, X and Y, are complements. The negative also tells us that. These are complements. Price increases, the quantity demanded of the opposite product goes down. Cool. Okay. Adam and Barb go to the store to purchase some lottery tickets. Without looking at the price, Adam says, I'll take 10 lottery tickets. Barb says, I'll take $10 worth of lottery tickets. Which is each person's price elasticity of demand for lottery tickets? Okay, so here's the difference. Are they indifferent to price? Yes or no? So Adam's saying, I'll take 10 lottery tickets, okay, regardless of the price. So he's indifferent of the price. So basically, he's not letting, and remember, what do we call the elasticity? Is the percent change in the quantity demanded divided by the percent change in price. So he's indifferent in this case. He's basically saying he's taking the 10 as a quantity demanded, and it doesn't really matter what price is. So because he's irreverent or doesn't really care about the price, Adam is going to be more inelastic. Barb, however, she's saying, I want $10 worth of lottery tickets. So what she's doing is looking at the denominator here and saying the change in price is going to dictate the numerator, is going to dictate my quantity. So she's going to be much more elastic because she's caring about the dollar amount.